Alright, so in this class, there are only four metric prefixes you need to know. Now, you probably know more than this already. One you may not know, but the four that you need to know are kilo, centi, milli, and nano. Alright? Those are the only four you need to know in this class. So what do they mean? Well, these are all sort of modifiers on base units of measurement. So what's a base unit? Well, like a gram is a base unit. Like a joule is a joule, J-O-U-L-E, which is a measurement of energy. That kind of joule, not J-E-W-E-L. Joule, a measurement of energy. Like liters is a base unit of measurement. Okay? So if we put kilo in front of gram, it tells us that there are 1,000 grams. So kilo means times 1,000 of the base unit. Okay? Times 1,000 base units. The base units, again, can be any of the units of measurement, basic units without the prefixes that we use in the metric system, grams. Let's see what I say. Liters, joules. Okay, that makes sense. Volts is a metric unit or a system of international units measurement. Okay, amperage. Okay, amps is a measurement. So we could have a milli or killiamp. All right, that'd be a lot of amps. That's pretty dangerous. All right. So centi is a 100th of the base unit. So it's times 1 over 100 of that base unit. Okay? So a centigram is 100th of a gram. And 1 over 100 is the same as 10 to the negative 2 of the base unit. Alright? Milli is 1,000th times the base unit, or 10 to the negative 3 of the base unit. And a nano, anybody know what that is? Huh? Not a millionth, it's a billionth. Okay? Times 1 over times of the base unit. Say what now? When we're trying to figure out solutions and the difference between solutions and colloids and suspensions, we use nanometers. If you're working with certain types of fluids that behave in a very unusual way, you're talking about particles of those materials that, I say fluids, it could be in a solid really, that have particles that are in the nanometer size. The top off my marker just seemed to have disappeared. For example, I lost it somewhere. Okay, let's see, I have a piece somewhere of a stained glass window out of a church. Piece of a stained glass window out of a church. Okay? And the way they get those colors and those reds and greens and blues is nanoparticles. Okay? And most of the time, it's like metal. Now, what color is silver? Huh? Gray? Silver color. So it's a shiny thing, isn't it? Okay? The fact is, though, if you make silver into different sized particles, really, really, really small particles. So tiny, tiny, tiny chunks of silver, you get different colors. You get silver solutions in a glass with these particles dispersed in it would be a type of solution with one size civil particle looks red. Another size civil particle looks blue. So it's amazing what these little tiny particles can do. Okay? Ferrofluids, those are really cool. I actually have some. I'm going to show you that sometime. Okay. All right, so this is the same thing as saying 10 to the negative 9th of that base unit. Okay? Well, what in the world does that mean in terms of our use? Well, if a kilo is 1,000 times the base unit, then it's also true that 1,000 base units equal 1 kilo unit. Does that make sense? And what do we call a statement like this, where one thing is equal to another? What? Okay, it's what we build conversion units from. But the statement itself, we have a different name for it. We call that an equality statement. Okay, yeah, it's where we get the conversion unit from, but it doesn't become a conversion unit until we make a fraction out of it. Okay, we put either this side over this side or this side over this side. Both of those are conversion units. Because we do that, the unit equals 1. That's what a unit means, okay? Got it? All right. So let's, in practical terms, then let's plug in something for this. Which base unit do we want to use here? Somebody choose a base unit. Grams. So 1,000 grams equals 1 kilogram. Does that make sense? All right. How about centi then? Well, if 1/100th of a base unit equals a centi unit, then the 100 of these equals a base unit. Would that be accurate? Do you understand why I'm saying it that way? Yes? Okay. So we can say that 100 centi units equals 1 base unit. Well, somebody pick a different unit. Give me another unit besides grams. Liters, okay? So 100 centiliters equals 1 liter. Now the reason I use capital L's, that's an interesting little story. Let me put that over here in kind of a box for a minute, okay? What's that? Somebody said, I don't know. I heard somebody else say something, but a 1, okay? What if I meant that to be a lowercase letter L? Kind of hard to tell, right? So, as a matter of practical matter, when we write liters or centiliters or milliliters or whatever, kiloliters, use a capital L, okay? Yeah, it makes more sense to use the lowercase L, but we want to be able to understand what we're saying too. All right, fair enough? Most of the time, we capitalize units of measurement only when those units of measurement are named for a person, but this is our exception. Everybody with me? All right, so that's an aside. Let's get back to our main point here. So what equality statement can we write for milliunits? Well, here's your example right here. We're not going to write a milliunit then. If 100th of a unit is a centiunit, and therefore 100 centiunits is a base unit, what about milliunits? How can we write it like that? Okay, 1,000 milliunits. 1,000 milliunits equals 1 base unit. All right. So what kind of units? What kind of units can we use? Anybody remember any besides grams and liters? Huh? Meters. We can use meters. Okay. In fact, somebody's out there measuring meter sticks right now. Look at here. They're measuring meter sticks right outside the door. How about that? Boy, how does that work out? Was that good? Was that just perfectly timed or what? All right. Sounds like somebody's cooking toast or something. Smells like it. Anyway, what is that? Y'all smell that? Okay. All right, so we can say 1,000 millimeters equals 1 meter. There's our example. How does that work? Got it? All right, last one. If a billion, 1 over a billion base units equals a nano unit, what can I say about nano units in a list like this? A billion nano units. 1, 2, 3, 4, 5, 6, 7, 8, 9. So a billion nano units equals 1 base unit. We could say 10 to the 9th nano units equals 1 base unit. How many zeros in this number? Well, that makes it easy, doesn't it? Yeah? Or no? Okay. Alright, let's see. We've used meters and liters and grams. What unit of measurement can we use this time? I mentioned a couple of them a while ago, if anybody caught it. Joules, there you go. So we can say 10 to the 9th nanojoules, and joules is capitalized because it's named for somebody, okay, equals 1 joule. Alright, how's that? That make sense? And those are the prefixes you need to know in this class. We could know others, but we can get by with just these. Okay, fair enough? Alright, now, with all of these, we can build, let's say, for any one of these equality statements, we can build 2 different conversion units. Okay? Let's just do this one right here. I'm going to build 2 conversion units from this one equality statement here. Okay? So I can put this on the top or that on the top. I can say 1,000 millimeters over 1 meter. Or I can say 1 meter over 1,000 millimeters. What is the numeric value of this fraction right here? 1. Yeah, that's what a measurement unit is. It's 1. Okay, that's why we call it a unit. Well, that's why I call it a unit. I actually have never found anybody actually who knows what they're talking about say so, but that's what I call it. That's why I think it's called a unit. All right. And you've been doing conversions all these years and didn't even know why we use them that way, right? Well, now you've got the tools to make any conversion unit out of any 2 things that are equal. That's a lot more powerful than just knowing that you can convert a dozen into 12, right? Because it gets confusing sometimes about what you multiply by. Well, here, this straightens it out. Yes? Think? Yeah. I hope so. All right. Well, let's try it out. Let's see how you do. Ready to try a practice problem? All right. Let's say we have 0.00001. No, 2 zeros. 001. And a 0 after that. Kilometers. Okay. And I want to find the number of millimeters in that. Can you use this information up here to do that? Do it. Using the system I've taught you of dimensional analysis, okay? Show me the work in dimensional analysis. You remember that? No? Work with a partner if you want to. Work with a neighbor. Compare notes. Figure it out. This is stuff you need to know for Friday's test. So, either review is, if you can review with somebody next to you, you can. Yep. What? Okay. I don't know if I'm gonna get to it today or not because let's try to get it first thing next week. Well, of course we won't be here on Monday. Y'all know you're not coming on Monday, right? Okay. All right. JC. No, you remember the guy at the Beacon?
Yeah.
That's what after you left yesterday, they told me you were called JC. I remember that. You stuck, JJ? Huh? You already got it? Oh, wow. Did you do dimensional analysis? Huh? You did? Well, that's what we did when we did conversions. We learned how to do that for canceling from multiplication to division. Remember all that? That was using a dimensional analysis process. Well, you have to set it up with the fractions to cancel out units. That's what I want you to practice here. Okay? Use that to practice. All right? Y'all must not like each other. Man, y'all won't work with each other. What's the deal? Bunch of cowboys in here. Loners. I want you to get in the habit of working with people, though. Working with each other. Helping each other out. Okay? We're all in it together. Peyton, you remember how to do this? You don't remember really? Who remembers how to do this? 2 people? Only 2 people? 3 people? Have y'all got the answer already? Yeah. Okay, go help somebody then. You can get up and walk around and help somebody. Okay? So JC, if you go to my YouTube channel and you look about the last, I don't know, 15 or so videos I've recorded, they're probably the ones that I've already taught this class. So it'll help you catch up. And you may have already had a lot of it, but if there's something a little bit different, you can kind of figure it out. Okay? So try to do that as much as you can. And we do have a test on Friday, so you have to decide if you think you're going to be ready or you need to catch up before you do that. Did I give you a copy of the practice test? Is there anybody else who doesn't have a copy of the practice test? You don't have one? You don't have one? You have one? I don't remember. 2 days ago? Oh. I think I gave it out to this place 2 days ago. That's correct. Only your rounding is incorrect again. Gotta have 2 digits because, and I haven't explained that, but I want to explain that now. That one? Okay. Okay. Oh, no, that's just the reference number. Don't worry about what's in parentheses. Yeah, and if you go to the website, in fact, let me show you right quick how they're working on this. The last website, I think you'll work with that. They'll tell you about that. Or you might don't get too much It's really easy. www.com. So the alternate instruction page. Okay? Scroll down here under one. All units have the same thing. That's the text. And unless I miss something, everything that I'm teaching you is going to be. Well, everything that's in there, you will find it. I don't think it's more than you do all of that stuff. But you can all just do as much as you can wrong. I'll help you. Okay? We'll get you there. Yep. Anybody else need a copy of the practice test? Okay. Who's still working on this problem? Nobody? Okay. Let's see, I'll mark it down. All right, you start with your starting amount. So 0.000010 kilometers. Okay, put it over 1. And we need to convert that, but we can't convert directly to millimeters. However, we have what we need to go from kilometers, kilo units, and the base unit, right? What's the base unit for this? Meters. So we have this equality statement. We have 1 kilometer equals 1,000 meters, right? So I can put 1 kilometer on the bottom, and we have 1,000 meters on the top. And using dimensional analysis then, I can cancel units, like I can cancel x's and y's in algebra. So kilometers go away. I'm at meters. Okay. Now I could do an equals here and calculate it, or I can go on and do a second step. Do all in one big step. Okay. Which is fine. You can do it either way. Now I also have what it takes to get from milliunits to base units. Right? Or base units to milliunits. Here's the base unit. I've even got the right equality statement here, right? That's the one. That's the equality statement I need. And if I put 1 meter on the bottom here, and I put 1,000 millimeters on the top, well, now meters cancel. And if I do the math, I have millimeters at the end. That's what I'm trying to find. And this process of setting it up so that you cancel out units or species and leave yourself with what you're trying to find, that's called dimensional analysis. Okay? The name for that is dimensional analysis. Alright? And so what do you get? 1.0 millimeters. Now, rounding. Let me explain something to you. If you put this in your calculator, you're going to get 1. You need to know how I got 2 digits. This number has how many significant digits? 2. Normally, if we have 2 numbers that we build a conversion unit, have an equality statement, build a conversion unit, you find the number with the least digits here, right? But these are actual counting numbers. These are infinitely significant. That's a defined relationship. So those are like ignored. Okay? They're infinitely significant when we're talking about the metric system like this. Now that doesn't apply with moles and grams, or with density where you have mass and volume. Okay? It applies to defined amounts, where 1,000 meters equals 1 kilometer and so forth. Does that make sense to you? Alright? So this is defined as being this, then we ignore those. Those are actual counting numbers. We don't use those for figuring out our significant digits. Remember, significant digits are determined from the measured or calculated numbers in the problem, and the only measured or calculated number in this problem is the first one. It's measured. So that's the only one we use to figure out significant digits at the end. Okay? Now, when we calculated it, we got a 1. I just put a 0 on there to get the right number of digits. If you could put it like this, you could say 1 millimeter, but we don't want to underline any significant digits, so doing the arrow and saying it's 1.0, I would accept that, but kind of unnecessary. But you remember how to round off when you have multiplication and division? I have to underline the insignificant digits and then use an arrow to show you round it off. Okay? And you can go back and look at that video too. It's on the YouTube page. Yeah. Huh? Yes. If you put 1, it's wrong. Now, does that mean that you're going to lose all points? No. Because I would count this is a point, that's a point, canceling a point, over 1's a point. There's like 10 points here. So you'd lose 1 out of 10. Does that make sense? The key thing is there's all these different steps and you're going to get credit for all the steps. Alright? I'm more interested that you have the steps right than in getting the right answer. Okay? Because if you get it right, if you do all the steps right, you're going to get eventually to the right answer. Alright? Yep.
So if we don't show a word, is that like...
Okay, let's say you only wrote down this answer right here. Your answer's right, but no work. You get 1 out of 10 points. Show your work. Good question. Thank you. But you got to show your work. Always got to show your work. I mean, it's multiple choice. You don't have to, but if it's a constructed answer problem, you have to show your work. Show me the work. The question was, what if it's 1 plus 1? I'm never going to give you something that simple, but come on, show me your work, okay? Let's don't even play the game, all right? Show me the work, all right?
You like put 1 plus 1 and then
I suppose, but when you're adding numbers or subtracting numbers in this class, you really should be putting them vertically, so you can round off properly in the system I've shown you, okay? All right. Y'all know what splitting hairs is? I never heard of that phrase before. How hard is it to split a hair? What's the point? What's the point in splitting a hair? Well, maybe you want to see what's inside, possibly. But the point is, sometimes you get it's like a useless exercise to try to pick it apart. Does that make sense? What I'm saying? We're just not gonna don't go there, okay? There's plenty of hairs to be split. We don't need this one today, okay? Fair enough? You don't understand this? Okay. Well, don't worry about the splitting hairs things. It was just an example, all right? I don't like to give these little phrases that people use commonly without making sure everybody understands what it means, because some people don't. Like I was explaining in the last period what getting on the stick means. Now, all right, it's not dirty, guys. Come on. Look, about 80 to 100 years ago, all airplanes were flown with a stick. There was no steering wheel. It was a stick in the floor. Now, you had 2 pedals, but those adjusted the ailerons on the wings. Okay, the direction of the plane was done by a stick in the floor. Getting on the stick was a pilot term for getting it done, basically. Okay, flying straight and level, getting things done. Okay, if you're going to get in the plane and go and take off, you're going to get on the stick. Got it? All right, so sometimes people take things the wrong way, but don't do that. All right.